Thank you. Thank you very much for coming to this session. I guess that probably your brain is a bit of a stressed after all this Ignite session. So I think that this is going to be a smooth session and some kind of funny session. Just keep in mind that prepare your phone because I will need your help. Okay, my name is Alex Soto. My Twitter is Alex Soto B. My email is soto@redhat.com. Feel free to, send me any question here, of course, or around the venue. But if it comes later, feel free to ping me in Twitter or email. And I'm the co-author of all these books, which probably the most important one for this talk is the GitOps Cookbook, which you can download it for free from Red Hat Developers Portal. I'll share with you the links later, okay? So, as I said, I need your help because we're going to play Rochambeau. I don't know if anyone here knows what is Rochambeau. No, probably not, but if I say the paper, scissors, rock, paper, scissors, then yeah, probably all of you have played the official, well, not official name, but it's known as Rochambeau, okay? And basically this is the game that we're going to play. You see that you're going to point your mobile to the screen, you'll open this application, you will have the start game. You push the start game, then you put the join game, and you will need to wait until I start the, let's say, the session. Because basically, what's going to happen is that we're randomly we're going to assign 2 teams in each of you, and you will compete each other for the, the rock, the scissors, and the paper. And then you see here that you will need to select if you decide rock, if you decide paper, you decide scissors, and then you do a submit move, and the most voted sign or shape for each of the teams, it will compete each other, okay? So this is the QR code. If you are not scanning the QR code, you also have the link. I'm going to scan it as well. And wait a second, and I'm going to start them. I missed. You will have this kind of certificate thing. That's because I don't have them. I'm going to share with you now the QR code again, no worries. But this problem is because I don't have, it just self-signed certificate, so yeah, it governs this thing. Keep in mind that this game is open source. I will share with you the links later on as well, so you are free to, there we explain how to deploy it. And wait, now. Source main resources. Basically, what I'm doing now, it's super secure, which is taking the password to the admin console, but at the end, well, it's just the admin console of this game. So, okay, now again, let's scan the QR code. Now we are ready. Going here. Let me scan. Yes, it works. So I got it all these certificate, blah blah blah. You need to, come on. Yeah. Okay, now, yes. But wait. Okay, all of you are in the game? Yes? Okay, then that's fine. Now, probably you see this start game, join, and so on. And now I'm going here. I'm going to set new game. Okay, and now you will need to choose everything. Okay, so here I put the name. You've got 20 seconds to decide which one you want. We're going to do 3 rounds, so no worries. I see that there are 6 papers, 3 rocks, 3 scissors between all of the teams. And there we go, it's tie. So we've got a tie. So both of the teams have chosen the same thing. Let's go to the next round. Again, 20 seconds. Just choose. Let's see if now we are in a better randomly. A lot of people choose rock, so maybe for the reason we always get it rock, and it's a tie. Let's see. No one chooses paper, I see. Okay, now team 2, the blue one, has won. Let's go to the final round. That's the last time that we're going to play. So it's just, I see no one votes for paper. Okay. I don't know why. but let's see the last. And it's a tie again. So, okay, the blue team has won this competition. But, of course, this talk is not about playing Rochambeau. It's about GitOps, because usually we've got this application, and now it comes to our manager and says, hey, I really like this game, but I would like to add some kind of AI on the game. And now, instead of choosing rock, paper, or scissors with a button, I want that you take a photograph of your hand, and then we check which is the shape, and then instead of pushing the buttons, you take a photo. So we need to implement a new service, new AI, training a new model, and so on. And of course, we want to put this on production. And yes, sometimes, when we want to put something in production, it's a bit hard, right? Because, yeah, this is our application that we want to put in production, and we see here there is a lot of people, right? Of course, there is always this guy, which is probably the product owner, the product manager, saying, no, we cannot go to production yet. Just skip. We need to, test it more. Wherever, all the developers there in the bottom saying, hey, we want to put into the production, and there is always one guy there. Then there is this one. Yeah, probably it's the architect, right? He's there saying, hey, I'm just surfing in this ball of software. Yeah, it's super cool, right? And oh, who's this one? Yeah, probably the DB admin, right? The database administrator saying, oh, please, we need to update the database. I don't know what we're going to do. So basically, this is what happened. And the big problem is this one, that when we just reach to production, probably it's going to be repeated and repeated over and over again, always the same words. So basically what we want to do is trying to make our movement to production smooth, right? So it's like, okay, let's go, all of us push to production and just repeat and repeat and repeat. So what is DevOps? DevOps is the key to meet the insatiable demand for delivering quality applications rapidly. Basically, yes, DevOps, it's not only about delivering software faster, it's also the quality. And basically, it means that we are involving all the company, right? It's not that developers and the operations are just working together, it's everyone. Developers, testers, the product owners, the security team, and so on, all together from day one working together. But what is GitOps? Okay. We have DevOps. We can think that GitOps is like an implementation of DevOps, okay? And one of these three main topics is that, first of all, we are using Git repository. So Git is the single source of truth for everything, not just your code, your application, but also how this application is deployed. In the case of Kubernetes, the manifest files, for example, all the manifest files to deploy the applications need to be in the Git repository. Also, the YAML files or JSON files that you are using for configuring the Kubernetes cluster should be in the Git repository. So we start treating everything as code. So not just the application code, also the infrastructure code. It's becoming code. And one of the great things about GitOps is that we can use the operations that we already have in Git for the infrastructure. For example, let's assume that we've got a database, for example, a PostgreSQL database running, maybe the version, 9, and we want to upgrade to 9.1. This process of updating the database version goes through Git, which means that we can send a pull request to this Git repository and say, hey, I want to update the database. Can you review that we are not going to break anything? So we send the pull request. This pull request could be deployed in our staging environment, validate that everything works, and when we merge this pull request, then automatically the database is updated. So, as you can see, GitOps is just a developer-centric approach to continuous delivery of an infrastructure operation. It's exactly the same thing that developers have been doing all their lives, but also for infrastructure. So, you might say, okay, that's really nice, but why GitOps? Well, basically, as I said, it's in a standard workflow. We all know Git, so why we need to create a new tool? We already know Git, so let's use Git. It enhances a lot the security because, as I said, now our infrastructure or deployment of the application just goes through a for example, a pull request so anyone can review, detect any problem before it goes to production. And if everyone, all the reviewers says, oh yes, it looks good, then we can merge to production and probably it's going to work. And what I really love also is about the visibility and the audit. Because at the end, everything is in Git. It means that probably you have created some comments on your Git commit, saying something like, we are updating the PostgreSQL database from 9 to 9.1 because there is some kind of security bugs that we need to fix. And they are fixed in this new version. Why is important this? Because maybe in 1 year, someone will say, hey, why we upgraded from Postgres 9 to Postgres 9.1? And probably nobody remembers. But if you are using GitOps, you will be able to do git blame, check the message, check the YAML file where you updated the image, and just get the description and say, oh yes, we upgraded for this reason. So it enhances a lot the audit of why the things are happening. And of course, also helps you on the multi-cluster consistency. If you've got several clusters, and probably you've got it. I'm not saying about multi-cloud or hybrid cloud, things like that. I'm just saying that probably you've got a staging cluster, a production cluster, maybe a performance cluster, and you need to manage all of them. With GitOps, it's super easy. You always do the same thing. And here there is a lot of strategies. For example, you can have a branch for a staging environment, a branch for performance environment, a branch for production, and depending on where you merge the pull request, you get this environment updated automatically. So now we've got GitOps. Probably say, oh, that's really cool. And I've got my application, which is in Git. I've got my infrastructure code, or the scripts, how to deploy my application. Also, they are in Git. So you end up by having 2 Git repositories. One that is your application. The second one, which is the configuration of your application. Basically, this is what developer does. This is what DevOps Ops does. Okay, so here is your application code, for example, the Java application, and here you've got all the YAML files in case of Kubernetes. So all the manifests that you have to deploy to Kubernetes are in this other Git repository. So when you do a change, you implement this new super cool feature of using the camera to take a photograph to play the Rochambeau. You are modifying here the code. Then we've got the continuous integration pipeline that run the test, create the container, push the container into the image registry, and so on. And then we need to send a pull request. Where? To this config Git repository. Because if we've got a new version, we need to update these YAML files. In case of Kubernetes, the deployment YAML file saying, hey, now the image, it's not the 1.0.0 anymore, it's the 1.1.0. So we need to send a pull request to this repository. Then, of course, let's assume that everything works. We merge to the main branch, which is the production environment. And there is a process here that it's just listening for any change that happens in this repository and apply these changes. In the case of Kubernetes, basically, it just push data or pull data from there. So what does this CD part really doing? Just these 4 steps, really simple. First of all, it monitors the Git repository. So just checking for any change in this config repository. If nothing changes, all is good. If you send a pull request, you merge to main branch, and you updated the version that says, hey, this YAML file has been changed. So I detect the drift, so I detect that there is a change, and I take the action. So basically, I apply these changes into the cluster. And finally, then I deploy, and I come back to the initial state, which is, let's wait for any other change. And what is Argo CD in all these things? Okay, GitOps can be applied in any kind of system. It could be Kubernetes, but it could be also bare metal or virtual machines. It's just a matter of choosing the right tool. Argo CD is just a tool for implementing the GitOps approach. This is what I showed you before, right? With this monitor, detect drift, take action, and synchronize the cluster state, but for Kubernetes. So it just works for Kubernetes. Basically, it's just a controller. It's just a part, or it's like a some kind of pods that are running in your cluster doing these 4 stages. What is a really nice thing about it is that you can control the synchronization order. Okay, so for example, when you are in the Kubernetes and you want to deploy a database, probably first you want to deploy the database, then you want to create the database schema, right? And then you want to test that everything is correctly working. So there is an order. You cannot apply the YAML files as we might think that it will be okay, randomly. We need to do it in this order. Deploy the database, create the schema, test the database is working correctly. So we need to offer a synchronization order. And this is one of the great things that offers Argo CD. You can choose in which orders you want to apply these files. Also, it has the rollback and roll forward to any Git commit. So what's happening if you go to production and you detect that there is a failure? How you get back to the old version? It's super easy. You do a git revert and done. Because you're changing Git, everything is in Git, you do a git revert, then the hit of the Git repo is again to the latest commit, and automatically Argo CD will redeploy the old version. It supports Helm, customized, and so on. So you can put there plain Kubernetes manifests, but if you are using customized or you're using Helm, as my example, Argo CD will detect that it's a Helm chart, and it will deploy this Helm chart. And you'll see that it has a really cool dashboard for watching how everything is working. So now, let's go a bit for the demo, because as I said, our manager wants us to deploy something new, a new cool feature. Basically, now we've got, again, the Rochambeau application, but you've got this capture move. So basically, you will see that you will open the camera. They will ask you for granting permissions to access the camera. No worries, we are not doing nothing with the photos. We are not storing them, we're doing nothing. Okay, so we just put capture move, then this will send to a Node.js frontend, which will go to a Quarkus backend application, and then finally goes to the OpenShift data science, which is this AI part. Okay, this basically we're sending the photo to there. It interprets if it's a rock, if it's a scissors, if it's a paper, and then just returns. So it's exactly the same thing, but instead of pushing buttons, we use the camera. So, as I said, you need to grant camera access for permissions. So, first of all, before you do this, we're going to see how we can deploy a new version. First of all, and let me do this bigger. Let me show you the application, which is here. This is the OpenShift dashboard. The Argo CD dashboard. Okay, you can see here, this is the application. This is the game with the alt application with the buttons. It's here. Then you can push here, and well, you see that this is the game. We've got a backend service, a frontend service, backend, and also a frontend. So it's everything here deployed. This is the old version, and now we want to deploy the new version, the one with the camera. What we need to do, of course, is code it. I've already done this. Push the container. I already done this because it's sometimes it's slow. And the last thing is update the Git repository with the new version. And to do that, this is the repository. I'm using Helm. Okay, and I'm going to the values.yml file. I'm going to edit from here. I know that it's not very real case, but you get the point. I'm going here to the images and say latest camera. Camera. Okay, so basically I'm just updating the image tag. I am updating the version to a new version. Now I do a commit change, and set a value, for example, update to camera. I just do a commit. And what's going to happen here, you'll see, is that there's going to be a rolling update. You see that things are doing some kind of movements because it's detecting the change. He detected that there is a new container there, so you need to deploy a new version, and it deployed the new version. You see here, if you go here, you see this is the commit, update to camera. This is the commit that I've created. So it detects the commit and just create this new change. So now it's time to go here again, scan the the QR code, and you'll see that you are going to the new version. Let me do it. Okay, so everyone is in the game again. So I'm going to refresh here. And, okay, let's just start. Now remember that you need to take a photograph of your hand with rock, paper, scissors, and let's play. Okay, you still have 20 seconds to take the photo. I don't know if the model is, I mean, that, you can see that we were like all our team, which are 5 people there just taking photos and just training the model, right? So it's, not a very well trained model, but we've done our best. I see that red win. Okay, let's do the next round. Yes, I still see that paper is not very popular. Now tie. Okay, let's go to the next round. The last one. Oh, now everyone is, yeah, scissors. Okay, a lot of scissors. So there is a lot of scissors. Basically, it means that both of the teams has one scissors, and then when we do scissors, is a tie. But the thing is that now the red team has one. Before it was the blue, now it's the red. So you've seen that deploying something new to a Kubernetes cluster with Argo CD is super easy. We just need to set up Argo CD to saying, hey, well, if you want, I can show because we've got time. Basically, here, to set up the Argo CD project, you only need to create a very small YAML file. This is the YAML file, okay, where you say, hey, look, Argo CD, please just start monitoring this URL to this path and this branch, and I want you to apply the changes to the local Kubernetes, so the Kubernetes where you are running, and that's all. And here I just said that deploy all the time and keep it safe, and that's all. I just apply this YAML file, and then automatically Argo CD will clone this project and apply all the manifests. And when I do a change, like you have seen, it will detect the change, detect the drift, apply the change, so it just deploys the new backend, and then done. We have been able to play the game. Now, I've lost here. Just we finish the presentation, we still have 5 minutes. Probably maybe you're wondering, okay, I've got Argo CD, but how I can run Argo CD into Kubernetes? I've got several ways. What I can make, or how can I, what Argo CD can manage for me, right? And there are several strategies. I would say that this is not the most used one. Maybe for big organizations, yes. Basically, it's having a central Argo CD running in a Kubernetes cluster alone. Okay, alone, or for example, on the testing cluster or any other cluster, and basically you configure a lot of course of Git repos, so because you are managing several applications there, and then Argo CD deploys this manifest to external clusters. Okay, so instead of having, like in this case, Argo CD running in the same cluster where you are running the application. In this case, you've got Argo CD in another cluster that is not running any application. And then you decide in which cluster you want to run the changes. That's one way. Another one is the cluster scope. Basically, in this case, it's like you've got Argo CD running inside the cluster, but what it's pulling from the repository is cluster objects. For example, like the creation of namespaces or the installation of the operators. You want to install operators into Kubernetes, It's something that is not of the application. It's something that it's from the cluster. For example, configuring the storage, the networking, and so on. I don't know, creating service accounts, all this kind of stuff. That it's not the application per se. It's the cluster management. It's done by Argo CD. The other approach is the application scope, which is the one that we've seen here. It's like having Argo CD running in Kubernetes, just having the applications, and then we only apply the deployment files of the application. This is what we've seen in the demo. So you've got these three things. Most of the time you will see this approach, because, the Kubernetes administrators, operators, usually didn't like a lot automate everything. They prefer to apply manually or just going to the UI and just click, 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 and so on. So that's fine. So probably you will see this approach. So, as I said before, you can download this GitOps cookbook for free. This is the link. You need to register. You will see that you go to developers.redhat.com, you register, and then you can download the book for free. Sorry. And also, I'm the co-author of Securing Kubernetes Secrets. So if you're interested not only in the GitOps part, but also how to manage secrets when you are using GitOps, then this is the other book, but you cannot download it for free for licensing problems. So yeah, you can buy it. This is the links. So the first link is these slides. If you're interested in Argo CD, we've got really nice tutorials in Red Hat. So it's dn.dev/Argo CD, dn.dev/Argo CD tutorial. That's really cool tutorials about Argo CD, GitOps, and some of the topics that we explored here. Also, there is the link of the book. And if you want to learn more about Kubernetes ecosystem, like Istio, Knative, and so on, you can go to dn.dev/learn. And we have done it, yes. So thank you very much. Hope you enjoyed playing the Rochambeau game. At least, I don't know if you learned something, but at least you know that paper, scissors, game is named Rochambeau. So at the end, you've learned something for sure. So thank you very much.